Hi, everybody. I am going to start my classes this year with an introductory lesson to seventh grade. Last spring, you missed out on the rest of your sixth grade standards thanks to darling COVID. So we're going to go ahead and start by finishing up sixth grade. So what you still need to learn more about, it's the sixth grade Indian standards for algebra and functions. We're going to talk about just basic equations and basic input-output tables. And all of that leads perfectly into seventh grade math because seventh grade is kind of like a pre-algebra. So let me show you what we're dealing with here. An equation is when you have two equal expressions. An expression's just a math problem, but it's not finished yet. It's not solved. There's no equal sign. An equation is the completed problem. So an expression is like a phrase as you're building a sentence for writing, and then the equation, is your complete sentence. So I could have the expression 3 plus 2 and an expression 4 plus 1. But once I put those together with an equal sign, now I've created an equation. Or I could have that same expression 3 plus 2, but this time instead of saying 4 plus 1, I can put a 5. Yes, it's just a 5, but that's an expression in and of itself. Put them together with an equal sign, and now I have an equation. So we're going to be dealing with algebraic equations. In an algebraic equation, you've got a variable standing in place of some mystery missing number. Variables, you're typically going to see lowercase because capital letters are reserved for formulas, like capital A for area, capital P for perimeter. Lowercase x is going to be the most common, but any lowercase letter is fine. You're usually not going to see an O because it looks way too much like a 0. And if you use a T or an L, give it a little tail at the end. Otherwise, it starts to look too much like a plus sign, or for an L, it starts to look like a 1. So I took that same expression, 3 plus 2, and set it equal to 5. So this is the same equation down here, but I pulled out the 2 and replaced it with a variable. So to solve this equation, you would have to find that x equals 2 because that's the missing number that makes that equation a complete sentence. Whoops. Let's see. There we go. Now it's cooperating. When you solve an equation, you want to do inverse or opposite operations. You're working backwards. You want to know what you had before you added or before you subtracted. So you use operations that undo each other. Adding and subtracting, they're opposites, they're inverses. They cancel each other out. Same way with multiplying and dividing. So still working with that same sentence, that same equation that I had, the 3 plus x equals 5, I see addition. The opposite of adding is subtracting. So instead of adding the 3, I subtracted the 3. But this equal sign works like the center of a teeter-totter. And you don't want to tip your teeter-totter. If you make one side lighter, you're going to have to make the other side lighter or the whole thing's going to tip. So I also took 3 away over here. And I was left with x equals 2, which we already knew. We knew 3 plus 2 equaled 5. But the great thing about equations is you can always plug your answer back in and check to see that you're right. Before you ever turn in your homework or your quiz or whatever, you'll know if your equation's good. If you substitute it back into your original problem for the variable and it doesn't make any sense, then you should do something different. This one, I took my 3 plus x equals 5, but instead of writing the x, I wrote what I thought my answer was. 3 plus 2 really is 5, so I know I'm good to go. So let's try a few. Remember, we're always going to be dealing with inverse or opposite operations. So on the first one, I'm going to separate this so that when I'm talking about a left side and a right side, we can really focus in on what I'm looking at. So the left side of the equals is where I find my variable. All my attention is going to go there. I see adding 8. I know that the opposite of adding 8 is subtracting 8. So I'm going to do that on the left. But remember, if you do that on the left, then you need to do that on the right. Don't tip your teeter-totter. Boy, I cannot talk today. This video is going well, isn't it? Then I'm going to go straight down the columns. So I've still got an x. The plus 8 minus 8, it's like it never even happened. If I give you $8, but then I take it away, we break even. Nothing ever happens. Bring down my equal sign. On the right, 25 minus 8 is 17. So I think my answer is 17. If I plug that back in, instead of x, I'm going to say 17 plus 8 equals 25. I know that's right, so I can circle it and call it done. Let's look at the next one. On the next one, with my variable, this time I'm looking at the right side. I see a minus 2. The opposite of subtracting 2 is adding 2. So I'm going to add 2 to the right, but again, don't tip that teeter-totter. I need to make the left side 2 heavier as well. Then I'm going to go straight down my columns. 16 plus 2 is 18. Bring down the equals. I still have a y. Minus 2 plus 2, it never happens. If I find $2 and then I give $2 away, I break even. So I think my answer is 18. I'm going to rewrite my original equation, but instead of writing 16, I'm going to, sorry, my goodness, what is my deal? Instead of writing y, I'm going to write 18 minus 2. 16 equals 18 minus 2. We know that's right. So 18 is my correct answer. Okay, let's see if I can continue to fumble over all my words here. I'm looking at the next problem. On this one, I see that I've got a 4 right beside my a, right beside my variable. When they're next to each other like that, it means to multiply. Think of multiplying as bringing things together in a group. If I separate those back out into separate groups by dividing them out, then I'm going to cancel it. So I'm going to focus on the right side where my variable is. The opposite of multiplying by 4 is dividing by 4. You're going to start seeing division shown a lot more with fraction bars. It just means divide. I'm going to divide both sides by 4, and I get 6 equals times 4 divided by 4. It's like it never even happened, and I get an A. Plug it back in to check. It would say 24 equals 4 times 6, and that's good. One more on this page. A fraction bar, I just mentioned, it really just means divide. So I could see it with a fraction bar, or I could see it with the actual division sign. But to cancel out division, I need to multiply. All of my attention goes on the side with the variable. So all of my attention is going on the left. The opposite of dividing by 3 is multiplying by 3. Those cancel. And I get m equals 18. It would have been the same over here on the one I have written on the right. The opposite of dividing is multiplying. So I would still get m equals 18. So I think the answer is 18. I'm going to plug it in and check. Instead of writing m over 3 or m divided by 3, I'm going to say 18 divided by 3 equals 6. We know that's true, so we know our answer's good. So what I would encourage you to do right now is to pause this video and try these 4 problems. Rewind a little bit, listen to my explanation again if you need to. Try to focus on how we're getting the answers. I know that number 1, you can probably look at that and know immediately what it is, right? But if you start learning why that's the answer and why your brain is doing what it's doing, then when we get to those harder equations later that involve multiple steps or fractions or negative numbers, they won't seem quite so bad. So hit pause, give them a try, and then hit play again and check your answer. Okay? Okay, so hopefully you did that. On number 1, so the first thing I'm going to do is separate it. And I realize my variable's on the right, so all my focus needs to go on the right. I see plus 7. The opposite of adding 7 is subtracting 7. I don't want my teeter-totter to go crazy, so I'm going to do that on both sides. And then I'm going to go straight down my columns. 9 minus 7 leaves me with 2 equals x. Plus 7 minus 7, it's like it never even happened. If you plug that back in, it would say 9 equals 2 plus 7, and that is true. Number 2, c minus 11 equals 10, so I'm going to separate it. All my focus this time needs to be on the left because that's where I find my variable. I see subtraction. The opposite of subtracting is adding. So I'm going to add 11 back in. And if I do that on the left, I need to do that on the right. And then I'm going to go straight down. C equals, I get 21. If I plug that in, it would say 21 minus 11 equals 10, and that is a true statement. Number 3, the 2 right beside the z means to multiply. The opposite of multiplying is dividing. So I'm going to divide both sides by 2. Those cancel, and I get z equals 18. Let's check it out. Even if you just check it mentally, like I'm doing right now, it really does pay to at least do that much when you're doing these for a grade. Why wouldn't you want to know right away if you have it right or wrong, correct? So I'm going to do 2 times 18. I'm going to write this one out so you can see it. Equals 36. That works. So that works. The last one here, 8 equals x over 4 or x divided by 4. All my attention is going to go on the right side because that's where my variable is. To undo dividing, I need to multiply. They're inverses. So I'm going to multiply both sides by 4. It cancels on the right, just leaving me with the x. And on the left, I get 32. The common mistake on number 4 is to just quickly glance at it and assume that your answer is 2, because we know 8 divided by 4 is 2. But if you plug that in, it does not make sense. If you plug in a 32, it says 8 equals 32 divided by 4. That one does make sense. Okay. Moving on. Sometimes you'll get multiple choice equations. In my class, a lot of the homework is multiple choice. While the quizzes are not, the homework is. So I would still encourage you to know the process for solving equations, but sometimes, especially if you're like on a standardized test for the state and you're starting to run short on time, if you have multiple choice options, you know how we were substituting the answer in to see if our answer was correct? You can do that with your answer choices. If you plug in an 8 for this problem, it would say 15 equals 8 minus 7. That doesn't work. But if I plug in a 22, it says 15 equals 22 minus 7. That does work. So I know that my answer is 22. I also could have gotten that by adding 7 to each side to do the inverse, to work backwards. But keep that in mind if you ever have multiple choice equations. Okay. See, I think I just, skipped too far. Writing equations for word problems. My advice to you is to pay really close attention as to whether or not they're asking you to use a certain type of equation. Sometimes you're going to look at it and know right away, well, I just subtract those numbers. But if they tell you to write an addition equation, you better not just show that you're subtracting the numbers or your answer's not going to be complete. Look for keywords. Draw diagrams. I'm a very visual person. It helps me if I see diagrams a lot with problems. Underline the important info. Ask yourself questions like, which one of these two values should be the biggest? Because sometimes that'll help you in setting up a subtraction problem, maybe. Don't forget to check your work. See if it even makes sense. If you're solving for the price of a pencil, and you get like $120, I bet you've done something wrong. So ask yourself if your answer could even be possible. Okay, so let's try one. Sam is 12 years old. This is 4 years younger than his cousin Dawson. Write and solve a subtraction equation to find Dawson's age. So here's what I know. I know Sam is 12. I know that he's younger than Dawson. I'm just going to make myself a little note that Dawson is older. When I read, a lot of times I'll read really fast, but my mind will kind of wander, and I haven't totally processed all I've read. Excuse me. So when I do word problems, I like to kind of take notes to myself, especially the longer word problems. That way I don't have to keep going back and rereading and freaking myself out because I don't know what I've just read, and it really does help me. So I know Dawson is older. I know that Sam is 12. And that's 4 years younger. I'm supposed to write a subtraction equation. So I'm going to go ahead and put something minus something equals something. Okay, Dawson is older. When you subtract, especially since we're not in negatives yet, usually you're going to want your bigger number to go first. So I am going to do D for Dawson. lowercase, remember. And I know that if I subtract 4, I get the younger age of 12. Or I could have said D minus Sam's age 12 gives me a difference of 4. I want to be really careful that I'm not just adding. I know that Dawson is older, so I could just do 12 plus 4, but I was asked to do a subtraction equation. That's why I'm not. When you solve this, you will find out by adding 4 that Dawson must be 16. Let's do another one. Jack and Annie together have $36. If Annie has 21, how much does Jack have? Write and solve an addition equation. Okay, so I know right away that I could do 36 minus 21 and find out how much Jack has. But I'm being asked to write an addition equation. Sorry, I keep coughing. I swear to you, it's not COVID. My allergies are like totally nutso today. I don't know if any of you have that problem, but today is just one of those days, I swear. Okay, so let's see. Let's underline some important stuff here. Together, they have 36. Annie has 21. And I'm supposed to do an addition equation. I'm going to go ahead and say something plus something equals something. Together would be the total. So I'm going to put that over here after the equals. And I know that if I add those together, I get the 36. So I'm going to say Annie's 21 plus whatever Jack's amount is would equal the 36. I just use J for Jack. You could always just do a generic X. You could use M for money, D for dollars. I also could have said J plus 21 equals 36, and it would work out the same. If I subtract those, I will find out that Jack must have $15. Input-output tables. Input-output tables are basically what we were just doing with substituting values in for the variable. You're going to put a value in for X. That's your input. Later, this will be written as a linear equation where you have an X and a Y. For now, you really just need to remember that your output is the same as the Y. So you put a number in, you get an answer out. Sometimes you'll see those written up and down vertically as just 2 columns, what you plug in, what you get out. Sometimes they'll write it horizontally. The top is what you put in, the bottom is what you get out. What you're going to see right now, because this is what you start seeing in 6th grade, and that's what we're trying to finish up here, you'll see 3 column tables. It's still what you put in and what you put out, but they give you the space in between where you can actually work it out in the problem if you want to. Now, for me, you don't have to use that middle column, but if it helps you, please go right ahead and that's fine. So here's an example. I have an input-output table. I'm supposed to use the expression 2x minus 1. Let's assume we've been told we need to plug in a 0, a 4, and an 8. So this is like 3 separate little problems. If I put in a 0, remember 2x means 2 times x. So I'm going to do 2 times 0 and then minus 1. 0 minus 1. Now, I know we haven't done negatives yet, but we can do this. If I have no money and I try to pay $1, I'm going to be $1 short. So I'm in the hole, -1. If I put in a 4, I'm going to do 2 times 4, which is 8. 8 minus 1 is 7. If I put in an 8, 2 times 8 is 16. 16 minus 1 is 15. That's my input-output table. On the next one, if I put in 5, so this time instead of x, I'm plugging in a 5, a 6, and an 11. Sometimes they'll just give you the random numbers. There's no rhyme or reason to it. Just do whatever it asks you to plug in. Other times you'll get to pick. Or sometimes if it's for more real world type problems, you'll choose what to plug in based on what makes sense for the problem. So on this one, instead of writing x minus 5, I'm going to write 5 minus 5, which gives me 0. Instead of x minus 5, I'm going to write 6 minus 5, which gives me 1. And instead of writing x minus 5, I'm going to write 11 minus 5, which gives me 6. So I'm just plugging in and seeing what I get. A lot of times through your math classes, you might hear some of us older teachers calling these plug and chug, because you just plug it in and see what you get out. I don't really know where that phrase came from, but a lot of people say it with math. If I want to plot points from an input-output table, on your coordinate plane, that's where you have an x-axis and a y-axis. Your x-axis is the one that goes side to side. Your y-axis is the one that goes up and down. I had a teacher when I was your age tell me, remember Y for yo-yo? A yo-yo goes up and down, so the y-axis goes up and down. So here, I am only looking at this first quadrant, because all the numbers that I'm plugging in and getting out for this particular problem are positive. So I don't have to draw this whole thing. I just focused on that first quadrant. My x is the one that goes side to side. And I knew that my x's were small, so I just went to 4. I mean, technically, I could have just put 1 and 2, because that's everything I need for this one. And then I kind of looked ahead to what my biggest was going to be, and I knew I was going to have to go at least to 5. So what I'm going to do is start plugging those numbers in, see what I get for my answers, and then I can go through and plot these points. So if I put in a 0, 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Like I said, if you don't need to use that middle column, you don't have to. If it helps you to actually write it out, that's fine. Doesn't bother me at all. Now, when I plot these, my x is my side to side. So when I put in a 0 for x, that means I'm not going to go right or left. I'm going to stay right in the middle. I got a 3 for my output. So I'm going to go up to a positive 3 on the y-axis, and I'm going to put a point right there. I didn't move right or left, so I want it to be right on that y-axis. When I put in a 1, so I'm going to go over to 1 on the x-axis, I got a 4. So I'm going to go up to 4. And when I put in a 2, I got a 5. So I'm going to go over to 2 and up to 5. Even though these are coming out to be in a straight line, they're linear, I'm not going to connect it. This wasn't an actual linear equation that I was given, and nothing told me to go ahead and connect it. So for now, I'm just going to assume that they're meant to be separate problems. All right, let's look at another. If it's part of a word problem. So this one says, Layla has 24 cookies for her guests. The function rule 24 divided by x, where x is the number of guests, can be used to find the number of cookies per guest. Create a function table, which I've already got started, and graph for 6, 8, and 12 guests. Now they told me that x is the number of guests. So the first thing I did was on my x-axis, remember that's the side to side, I went ahead and labeled number of guests. I knew I was going to have to go up to 12. So I just went by 2s. As long as you count consistently, it's fine. If you want to put 12 individual ones, that's okay. And then I just kind of looked ahead. I knew I was going to divide, so I knew my y-axis numbers weren't going to need to be huge. The y-axis is showing how many cookies, and I just went ahead and went up to 5. Okay, so on my input-output table, I'm going to plug those numbers in, see what I get for y. I'm going to put those on my graph. They're asking me to use 6, 8, and 12. If I do 24 divided by 6, I find out each guest gets 4 cookies. If I do 24 divided by 8, they each get 3. And 24 divided by 12 guests, they each get 2. So over here, to plot my points, I'm going to go over to 6 guests, and I'm going to go up to 4 cookies. I'm going to go over to 8 guests and up to 3 cookies. And then over to 12 guests and up to 2 cookies. That's all there is to it. Okay, so that wraps up this introduction to 7th grade. Hopefully this helps you with your homework or helps you study for quizzes. If you came across this and you're not one of my students, hopefully it helped you and you got something out of it. If you need any more help, I do have an actual YouTube channel. It's Math with Luger. I will be posting lesson tutorials for all the standards that I teach in my 7th grade class. If you are one of my students or a family member of one of my students, don't forget, I know I've sent this information home, but I do post weekly updates to my classroom Facebook. It's Luger's Math Class. If you need to get in touch with me, please feel free to leave a comment on this video or email me. My students, you also have information about how to contact me through my Google Voice number. So thank you so much for listening. Sorry, I kind of tripped over my words sometimes there. But anyway, hopefully you found it helpful. See you next time.